So other ways that are more interesting, so just very simple ways to protect our plants. So plants can be grown successfully irrespective of weather conditions. A wide range of plants can be grown than would be possible if we only grew indoor. This is very simple outdoor garden, and all they did was put some wire and put a piece of, it's called shade cloth over it. And it's very light, so one person can pick it up and move it. So when I'm starting seedlings, a lot of times the baby plants are not easy for this amount of sunlight, maybe here in the tropics particularly, or if it rains. So I can protect these seedlings in the first week to 2 weeks from being rained on. So if I'm worried it's going to rain tonight, I put the cover so if the rain doesn't beat down the seedlings. So it's a really misnomer about people come to Asia, especially in Thailand, and they go, oh, it's a rainy season, it should be a lot of food, right? No, you go to the market and the price of food can swing by 20% up. All the small growers don't have don't do anything right. So what happens is all the plants get beat down, so they're not able to start seedlings. So it rains so aggressively that it smashes the plants. So it's really hard to get the seedlings. So techniques like using our nursery, right, to start seedlings to get them strong enough to transplant. Because if I try to start it directly in the beds, which works 8 months a year, no problem. It doesn't rain, right? So 8 months of the year, I have sprinklers that are very gentle. I can start my seedlings directly in the bed. But for 4 months of the year, I really need to start my seedlings in my nursery or greenhouse because of the rains. So these are ways to protect our plants. Other things that we can look at is like what they describe as half-hardy plants that can be grown and planted out later when the risk of frost has passed. So once the frost is finished, I can put out plants that are more susceptible to colder temperatures. So I start to look at the type of plant that I plant at different time periods, which gives you a garden calendar. So you actually want to get a calendar, and you can look these up online. Most places have them for your particular, where you live. So look up your name of your country garden calendar, and someone has already figured out all the plants that you should plant throughout your growing period so that you can maximize the growth. So environmental factors that can be controlled and improved, and this will aid in your plant growth. Here's really nice tomatoes, and they made a net so the tomatoes can grow onto the net so that there's less stress on the plant. Really nice big tomatoes. So look at aided growing conditions. Those are also nice. So that brings us to, in these conditions, the 3 types of plants that you may be able to look at. Annual plants, biennial plants, and perennial plants. So we want to see the differentiation. Why are these different? And what advantages or disadvantages can we construe from each one of these? So in annual plants, the annual plant is a plant that completes its life cycle from germination to the production of seed within 1 year, and then it dies. So we need to save seeds or have a condition where it drops and can regrow. Summer annuals germinate during spring or early summer and mature by autumn of the same year. Winter annuals germinate during the autumn and mature during the spring or summer of the following calendar year. And that's why it's important to know which ones grow in your area so that you can have a calendar to say when you should grow these, because you see how they're in different growing cycles. So biennials. A biennial plant is a flowering plant that takes 2 years to complete its biological life cycle. In the first year, the plant grows leaves, stems, and roots, which we call vegetative structures. But then it enters a period of dormancy over the colder months. Many biennials require cold treatment or ventilation before they will flower. Ventilation. What that basically means is like stratification. The seed, if it doesn't go through winter or freezing, won't germinate. So I can grow these plants here in the tropics even though we don't have a winter. And how will we do that? So if I buy the seed from someone, let's say they ship it to me over the internet, then I'll take it and put it in my freezer. And I'll freeze the seed inside the freezer for 2 to 3 months, representing it's in winter. And then when I take it out and I plant it, it'll germinate. But if I didn't do that, so they had harvested the seed, but it never went through winter, it won't germinate. So that's a way for me to save seeds and then stratify them over a life cycle. So biennials. During the next spring or summer, the stem of the biennial plant elongates greatly, or what is described as bolting. We can see this in a lot of our vegetables, especially like spring onions. This typically makes biennial vegetables such as spinach, fennel, and lettuce unusable as foods. So these type of plants, we can utilize them, but we need to understand this growing period and when we can exploit it. If not, it'll do it at the wrong period and you don't get the food that we would describe as food. The plant then flowers, produces fruits and seeds before it finally dies. So we eat them at the adolescent stage. And perennials. The perennial plant is a plant that lives for more than 2 years. The term is often used to differentiate a plant from shorter-lived annuals and biennials. The term is also used to distinguish plants which have little or no woody growth from trees and shrubs, which are also technically perennials. So this is a perennial, what we might say perennial vegetables, right? Versus perennial trees. So a vegetable that I can plant that would last more than 2 years without, say, dying, something like that. So we can look at those. So if we try to look at the basics of these, we went through our plant propagation techniques. We want to ensure the maximum chance of success. It's best to propagate plants during the time of a rapid growth, spring or a rainy season. Then you have plenty of nutrients and water for young plants or cuttings. So here's basil. Basil's super easy to grow. You just go to the basil bush and you go to the end of the basil and you cut the end off and you just stick it in the soil. It'll root in the soil that you took, and it'll regrow a new basil. You can do the same thing with a tomato plant. So if I don't want to grow tomato from seed, I can take a cutting and I can regrow the cutting of a tomato, and I'm sure I have the same tomato. So we start to learn those. And if we do that, we have control systems which are going to have growth and development. So the external control systems, think about your day length. We can control the amount of sunlight. We can control the temperature, which is cold and warm season plants, and we even can, some commercial growers would use plant hormones. So they'll spray hormones inside of the glass houses in order to regulate what's happening with the plants. So for instance, I want them to all fruit at exactly the same time so that I can bring all the fruit to market at exactly the same time. So they may use hormone regulations to assure the fruiting. So this is called photoperiodism. So there's a plant response to day length, and 3 different responses have been identified in plants. The most usual associated with triggering of flowering. So this fruiting and or flowering aspect, when we can set flowers all within a certain time period, the fruit will come out at the right time, and then that's good for harvesting. So these are described as short day plants, long day plants, or day neutral plants. So again, dependent on where I live and my gardening calendar, I'll have these different types of plants spread over the different season due to the light availability within my country, especially in temperate climates where light is less than, say, here in the tropics. So you can look at that. So the plants balance and they trigger this response. So we have this sun plant, like a sunflower, loves full sun. And if we go all the way to the end, we may have other plants that are more like a lettuce, was not going to like that full sun, especially not in a tropic condition where it's very hot. And that's where we'll have issues with our lettuce becoming bitter. We won't have enough water availability to match the amount of sunlight that we have, and then we don't get, like say sweet lettuce, we get like bitter lettuce, which is not so good. So if we look at those plants, some examples, think about like the Christmas plant, I like to call it. So at Christmas, we always see the chrysanthemums. Well, why? Because those plants are a short day plant. So at the peak, or December 21st, right, the shortest time period of the year, they tend to bloom. So there's a relationship. So we can start to look at plants and their relationship to the amount of sunlight. So flowering is triggered by shorter periods of darkness, and in general, these are spring and summer flowering plants. Some examples, hosta, lobinia, or the radish. So from a vegetable standpoint. A lot of our ornamentals, we see this. So they use this in ornamentals, and throughout the year, this tree is popular at this time of year, or plant, and this time of year. But there you go. And they all require short nights for flowering. So these plants are unaffected by the day length and the flowering for certain periods of growth. Examples of these would be tomatoes or bongans. So these are day neutral. A tomato doesn't really care, it doesn't matter or mind if there's a little less light or too much light. You still can get a good yield. So native to colder climates, we see what we could describe as cold season plants, and they tolerate temperatures below freezing. Growth is poor at warmer temperatures, including this would be like cabbage, broccoli, lettuce, daffodil, tulip. So I can grow any of these here, but they all come out very poor, or what I would consider as not very great or edible. They're really small. They a lot of times come out bitter or don't come out right. They look deformed. So these are the concept of like temperate plants, cold plants versus tropical plants, and these are the things that are hard to grow. So these, but they do have temperate plants considered warm season plants. So if I transplant them to the tropics, these would do well for me. So this also helps me to identify plants that I can take from one place to another and how they're going to affect. So they prefer temperatures above 21 degrees C, and they suffer frost damage at freezing temperatures. Examples of these, tomatoes, sweet corn, beans, and melons. So any of those derived in temperate, but can be grown in the tropics. So if we do that, last thing we can look at is plant hormones and the relationship to the hormones that are given off by plants and their relationship. So plant hormones are chemically produced by the plant, and they control growth and development. The plants have an internal control system for hormones, similar to us. And there's 5 hormones which are important for plant growth. So oxium, gibberellin, catechine, acetic acid, and ethylene. What do? Well, they promote cell elongation so the cells can grow. So growth, stimulate cell division, again growth, inhibit growth, increase the growth, inhibits leaf drop. It could produce, it can increase the production, so we can see the sequencing on the drawing. We have weed killers, rooting powders, increase fruit yields. So there's lots of things when you go to a market now that we can put onto our plants that have all of these perceived increases in side effects. Typically in a permaculture situation, we don't use these, okay? But it's interesting to note that in some things are interesting. If I take, for instance, my mango, right? So it's mango season. We go to harvest mangoes. They're not fully ripe. If I put the mango with the ripe banana, guess what happens? It ripens. The hormones being released from the banana will ripen the mango. So then I can have ripe mangoes because I just have to put the mangoes with the bananas. So these are things where we can do that naturally, but then scientists can create that hormone, the banana off-gassing they call it, that will ripen other fruits. So that's what they're normally doing. One type of fruit makes a lot of this gas, bananas particularly, and then you can ripen any other fruit with that banana.